Hi everyone, thank you for joining our Enterprise Track reInvent session on how Capital One manages the health of their applications on AWS. My name is Tipu. I'm an engineer in AWS support. It's my pleasure to introduce Eli.
Hello all, my name is Eli Stull. I'm our product manager here at Capital One. Currently, I'm in our cloud engineering space. I've been here for about 8 years or so now in various product management functions, so I'm looking forward to our discussion today.
Thanks, Eli. Today, we're going to talk about Capital One's fleet, the large scale of their applications, resources, and how they manage this across accounts and regions. Eli is going to walk us through how they actually manage this and monitor it with one fleet. Then, I'll cover how we further augment the management of fleets through automation and machine learning. Lastly, we'll tie it off with one tangible example of how to bring this all together for forecasting capacity. Over to you, Eli.
Thanks, Tipu. Today I'll be discussing our approach to monitoring the health of our cloud infrastructure. First, I want to provide some brief information about Capital One. There may be some of you that are not familiar. We are a financial services company. We started with credit cards in the early 1990s. We've since expanded to offering banking services, so both for personal, small business, and commercial banking, as well as auto financing. All right, let's dive in and discuss a bit of our history in regards to technology. So since Capital One's inception, our technology had been data center based. While this was the norm at the time, it required massive infrastructure management efforts and created extremely long timelines for feature delivery for our large applications. As cloud technology has evolved, Capital One has adopted an all-in cloud-first approach for our technology delivery. This strategy has significantly increased our feature delivery speed. We have gone from creating and managing giant monolithic applications in data centers to the cloud, which requires its own challenges of hundreds of accounts with thousands of applications using millions of resources. Releases used to be monthly or weekly at best. Now the releases, we can have releases anytime, from on demand, any time of the day or night. So given this scale, our new cloud-first approach required a unique monitoring to ensure we are well managed in the cloud. We had some things to consider when building a solution. We have operating boundaries. Application teams are leveraging many resources across multiple accounts and regions. We have application team operating tiers. Account use is modeled after SDLC environments, meaning we have separate dev, QA, and production environments. Also, since given we're a bank, we have unique regulatory requirements. This includes regulatory separation of concerns, so environments must further be segmented by use case. We determined some key requirements when designing a solution to monitor and alert on events, which we call our North Star. To start, we're collecting events from each account at Capital One, and these events range from informational to critical issues. Timing is key if we're to be effective in communicating these to teams across the enterprise. So we want a process that's driven from the events being pushed by AWS Health. We need to consume the events in as close to real time as possible. We then wanted to have the fewest number of environments to operate in at once, meaning we wanted to make sure we had a centralized solution for data collection. This would reduce our overhead and our complexity for our application. We realized that as Capital One cloud footprint continued to grow, we would be ingesting and triaging more and more events. We needed to make sure we can handle an unpredictable workload. As requests come in, the application should scale automatically. While providing visibility and enriching these events, we need to account for stakeholders who cannot access a console. With that in mind, we needed to ensure that we had a way to share this information, not only through a UI, but through notifications, so stakeholders could receive information wherever they are. The less components we have to actually actively manage, such as EC2 instances, the better. This allows us to focus on feature delivery instead of infrastructure management. We then thought about which AWS services would work best given our direction, our North Star. Which services would work with our current strategy, but would also grow with us as we discover new use cases for application in the future. So starting at the upper left hand of the slide, we use CloudWatch rules from AWS Health. This allows us to capture the events in real time. Moving clockwise, once the event is captured, we use CloudWatch event busing to move events across the accounts. Given the nature of our environment, which consists of hundreds of accounts and thousands of applications using millions of resources, this service was a really good fit. In the lower left, we use CloudWatch, Kinesis, Lambda, and RDS. These services allowed us to meet several needs of a new application through growth. We selected these services for their built-in auto-scaling and simplified scaling pattern functionality. These services also allow for built-in retry patterns and managed servers. Moving to the bottom right, we selected Vue.js and GraphQL to provide the needed backend in order to deliver a robust platform of exposing process data through flexible APIs. After selecting these services, we're off to rapid prototyping a solution, which has turned into what we have today. We call our solution OneFleet. In summary, OneFleet is a cross-account, cross-region solution to aggregate and report on the operational health of AWS estate at Capital One. Our application automates notifications by combining the events we receive from AWS Health with the information that we have about our applications to ensure our notifications are optimized to the right channel. Meaning we're notifying teams at the right time and in the right channel to reduce time to detection, event detection, as well as time to resolution. On the right, you can see an example dashboard of one of our support channels. This is a real-time dashboard which highlights events with the greatest impact using color coding. So green, red, yellow, green. From here, teams can dive deeper into the information by going to our application, OneFleet. Our application uses automation to enrich AWS Health events with our own data to meet several current use cases. So currently, OneFleet offers real-time notifications to impacted teams of issues and schedule changes. It establishes a blast radius. This allows us to support teams to determine how broad an event is and quickly identify and mitigate impacts. It provides a single pane of glass to identify and monitor events. So we provide both high-level views, so our dashboarding for an event detection, as well as in-depth details about the event to dive in, and really assess the impact. We are also correlating events to incidents. This means tracking events through the lifecycle. So as the event is generated through its close. This helps us define our future strategy and allows for our applications to provide the best event triaging and send the right notifications to the right team at the right time. We have the ability also to monitor and request increases for service limits. We are starting to build self-service capabilities for teams to better manage their infrastructure. This process is notification-based, so teams only need to take action when it becomes critical. So service limits are just the start. Okay, now let's walk through a sample use case we have here at Capital One about modifying. So we're going to talk about notifying application teams which are using AWS resources when an upcoming scheduled change is scheduled to occur at AWS. So first off, let's talk about the problem. We have many application teams, again, using a lot of services, many different accounts. This typically averages out to about 400 scheduled changes per month. OneFleet starts by collecting the changes from AWS Health, and then combines that information with the data we own, so we know who owns those accounts and services. From there, we notify teams via an escalation workflow. We provide notification options to teams to ensure that they're notified in the channels they spend the most time in. So whether that's Slack, PagerDuty, email, we can notify them however they prefer to really make sure they're not having to move away from developing or investigating to get the notification in the correct channel. So this process ensures scheduled maintenance events are remediated before the scheduled change date by providing both the visibility and then allowing teams to build that schedule into their agile processes and helps us prevent incidents from occurring. At the bottom of the slide, we've got a high-level diagram of our process flow. So starting at the left, AWS generates the event based on a service. We then extract and observe the event before processing the event, determine who should be identified. The event is then distributed via the consumer's preferred channel based on event type, as we talked before. So Slack, email, PagerDuty currently are the options as we build out additional options. So once a team receives an event, they can start taking action to mitigate. So to wrap up my part of the conversation today, we provided a high-level overview of Capital One's journey of where we came from as an organization as far as technology, how we addressed our shift in infrastructure strategy, and then the solution that we built using AWS Health to provide visibility insights to better support our operations. So thank you for your time today. Now I'll turn it back over to Tipu from AWS.
Thanks, Eli. It was really great to hear about how Cap One manages the scale of its fleet, not just across regions, but also across accounts, and then enables automation and notifications as well. So now I want to talk to all of you about how we've learned lessons about scale in Amazon.com and also from our other customers. So there is some work that can be done to conquer the scale and to better manage your fleets, to reduce the amount of work that you have to do manually. No one wants to do manual work, right? Every year, we have an event in Amazon.com called Prime Day. This is where we open up sales for a lot of products for an entire day or more, and a lot of traffic comes to our site, since there's a lot of buyers who come to shop. And there are a lot of distributed systems that need to prepare for this shock to the system, for this large-scale event. We start planning a significant time before the actual event. We follow an infrastructure event management process. As you can see here, we start planning almost 1 to 2 months normally for capacity. So to analyze and forecast capacity, we have to get data from different sources. So usage data of AWS resources, current and in the past, what happened in the past event. Business data about what the traffic patterns might look like due to the changing environment of the business, as well as any other factors that might come into play to forecast capacity. So that's one of the first things you can see in the beginning of the graph. Now, as we start working towards the event, there is testing, there's game days, there's playbooks, there's automation. We have to make sure that our website can handle the scale that's needed to make sure that our customers have a great experience. And that does require planning. But you can probably see here that there is some room for automation, right? Well, once we start scaling up, you can see 1 to 3 days before the event, the amount of traffic really starts to increase as well. So we scale ahead of the traffic so there's no impact to the customers. And then once the event is good, once our war rooms have made sure that there's no real problem during the event, we also have to scale down the resources. That's really important because as we scale down, we have to ensure that operations continue to flow normally and that our normal systems can continue to handle our operations. We also have to make sure that any unused resources are gracefully removed. Any existing connections are not teared down ungracefully, and that unused resources that are doing nothing can be safely removed. This brings us to the problem of scale. When we're talking about doing this across so many accounts, thousands of resources, so many applications, so many teams involved, just like Capital One, there's a lot of room for error, especially if things are done manually. And that's where we're going to focus a lot of the talk here, about how you can use automation and intelligent insights and even machine learning to make that job easier. So to conquer that scale, we have a few opportunities. It's not just challenges. These challenges bring great opportunities because with our large scale of resources, we can also optimize them more efficiently. The long run, we can have cost benefits as well. With our large scale, we can have better fault tolerance. But this means that we have to design the right way and that the resources have to be presented or created or provisioned in the right way. Performance gaps also have to be detected and eliminated, preferably automatically. And then unused resources should be removed so that there aren't unexpected bills, so that we can also optimize for cost. At AWS, our top priority is security, so that's a key part that also needs to be accounted for as we scale. There can be no compromise on that. Now, let me tell you about some intelligent services that can help you to accomplish this task of conquering complexity and handling scale. The first is Trusted Advisor. So AWS Trusted Advisor gives you best practices across 5 different domains: fault tolerance, performance, security, and limits as well. It surfaces these insights or best practices in the form of statuses. Red meaning action is immediately needed. Take the example of security, where there is something that requires urgent action. Take yellow as something that is a nice to have. For example, you have unused resources, probably in a dev environment, that can be scaled down. And then green, where you're doing just a great job. So Trusted Advisor surfaces these insights via API, CloudWatch events, and even CloudWatch metrics. So you can use those as hooks for your automation. I want to tell you about one more data source. So just like Trusted Advisor, there are other AWS services that can give you intelligent insights. AWS Health is a service that gives you information about events and incidents that you can then use to implement automation. It has a console called the Personal Health Dashboard. It can show you things like schedule changes for your resources where you might have to take action. So think about an EC2 instance that is scheduled for a scheduled action, and if you don't take action, it could impact your applications running there. Now this is ripe for automation. And so AWS Health surfaces these insights in the console through the API, CloudWatch events as well. So you can pipe these events and then implement automation as well. Now, just like Trusted Advisor and AWS Health, there are other services that can give you intelligent insights, such as AWS Inspector, which gives you security insights, or Cost Explorer, which gives cost insights. However, the design paradigm is the same. You take the data from these intelligent data sources, these services, you then set up policies for automation, and then you safely implement the automation on the resources for which they need to be implemented. And what do I mean by the policy? I mean that you want to ensure that, number one, the automation can only have the capability, the right security credentials to implement automation on the resources on which it should be implemented. As an example, you might only want the automation to be implemented on your dev resources, whether those are in a dev account or a dev CloudFormation template, or in a or just development stack with tags. And so that is why with great automation comes great responsibility, and this tagging or these policies are quite important. All right, we learned from Capital One that there are many teams involved to make a large enterprise, that there are many applications, thousands of resources. And just like Capital One, we hear from customers that multi-account support is quite important. And so services like Trusted Advisor and AWS Health do indeed support multiple accounts through AWS organizations. Now, these insights that we talked about that you get from health events or from Trusted Advisor best practices, these can be aggregated. These can be put into S3 buckets as an example. And from these S3 buckets in a centralized location, you could have automation run across accounts. So in this example, I show you Trusted Advisor surfacing insights onto S3 across accounts, then automation taking place through Lambda across accounts, and then for bulk analysis or for broad areas of improvement, you can analyze all this in Athena or QuickSight as well. Great. So far we've discussed intelligent sources of data, and we've briefly touched upon how to automate actions upon them. I want to tell you about some services that can make this even easier, or make what was previously not possible much more possible to automate. So one of them is Amazon Forecast. Amazon Forecast allows you to take time series data and get a forecast of where things are going to be. It can predict, it can allow you to create customized forecast models. So it can be quite plug and play as well, but it can also allow you to get good accuracy with the right customizations for your models. Earlier, I was talking about Prime Day, right? You might have remembered that we had to analyze our capacity needs, predict what we're going to need for the future. And so Amazon Forecast is one of those services that can really help to make that task easier. Now, this service can take data in multiple forms. It allows you to choose the algorithm, allows you to do the feature extraction, and then tune the hyperparameters as well. Once you have trained and optimized your models, you have a customized forecast that you can trust. And this will become quite important in one of the examples that I'm going to share. Okay, all right. So we discussed these services that give you intelligent insights: Trusted Advisor, AWS Health on the left-hand side, Amazon Forecast. I give you examples of some other services like Inspector. There's also additional services like Config, where you can set up custom rules to give you insights. Now, the pattern that I want to show you here is fairly common across these. You can pipe these events into CloudWatch events or EventBridge, and then have the targets for those events as these services on the right side. And these will implement the automation that you want to implement with the right policy. Now, in the previous example with Trusted Advisor, I showed Lambda, where Lambda is a scalable serverless service that allows you to implement code. And step functions is actually very useful with AWS Lambda, as your automation can get more complicated. Step functions can make sure that you can orchestrate across multiple serverless components. Similarly, AWS Systems Manager allows you to implement automations not just on the AWS services, but also on the operating systems through run command, whether it be Windows or Linux. Lastly, I also want to highlight code pipeline. You might want to have your automation first implemented in a test environment as part of your pipeline. And then if that stage passes, you have it go to the production environment as part of your natural pipeline. Okay. Now, let's bring it together. So we talked about how to do this theoretically, right? And so coming back to that Prime Day example, we have to forecast our capacity, and then we have to scale up our resources. Rather than doing this manually, it is possible to bring in automation. So here I have my AWS Service Data. As in this example, I show EBS, or Elastic Block Storage. You can have EC2, DynamoDB, whatever you preferred as the inputs to this. But the usage data goes into forecast. We have Trusted Advisor also surfacing service limit data. You can also use service quotas. You have CloudWatch data showing AWS usage, or it could even be more specific metrics if you prefer to use them, like network, in case you want to forecast network. You take in these inputs, you transform them if needed using something like a Lambda function. You put them into an S3 bucket. So I have my data sources, I have them flowing naturally through a pipeline into an S3 bucket. From this S3 bucket, Amazon Forecast takes the data in and then starts creating a forecast. I talked earlier about how forecast allows you to choose your algorithms and to optimize your model. Once you have confidence in your model, once you have tested it, at that point, you can really trust the predictions that you get from forecast, and then you can implement automation. So once you have the trusted forecast, you can implement automation. How do you do that? Well, forecast will put your outputted forecast into S3. Through the S3 put action, you can have Lambda functions implement automation. The Lambda functions can also be orchestrated by step functions, as I mentioned earlier, in case it's more complicated. But what will Lambda do? Well, in this case, in my example, I am having my Lambda function increase my EBS capacity. If I'm running close to my limits, according to my forecast, I can have Lambda talk to the service Quotas APIs to increase my limits for the accounts. And of course, this can be done across accounts. Now, all of these automations, as I alluded to earlier, need to be done through policies. In case something is sensitive, you can also just have notifications. Notifications are quite powerful, as we learned from Capital One. These notifications can alert the right teams across accounts to make sure they take the right action in case automation is not possible. I hope that these insights into how to use these AWS services, take best practices, and implement them through automation, and then augment them further through machine learning have been useful to you. Thank you for your time.